Now that we've proved that sine theta squared plus cosine theta squared equals 1, and tangent theta squared plus 1 equals secant theta squared, we can prove that cotangent theta squared plus 1 equals cosecant theta squared. So let me get rid of these. So if you haven't checked these, you can check these out in the description down below. I'm just going to link the videos where I proved these. So let's prove this. So to do that, we're going to need a right triangle, and we're going to say that this is theta, and this is A, and this is B, and this is C. And we know that cotangent theta is equal to cosine theta over sine theta. And we know that cosine is adjacent over hypotenuse, so that's B over C in our case. And we know that sine theta is opposite over hypotenuse, so that's A over C. And when we divide, we get B over A. And that's our cotangent. And we can just write here cotangent theta equals B, so equals B over A. And we also know that cosecant theta equals 1 over sine theta. And we know that, so we know that sine is A over C, or opposite over hypotenuse, so A over C. And so this is equivalent to C over A, and we can write that here. So cosecant theta equals C over A. And now that we did that, let's see what cotangent theta square is. So we know that cotangent theta equals B over A from here. So if we square both sides, we get cotangent theta squared equals B squared over A squared. And just like that, we can see what cosecant theta is. Cosecant theta square is, so cosecant theta is C over A. We know that from here. And if we square both sides, we get that cosecant theta squared equals C squared over A squared. And we know, we have to know what cotangent theta squared plus 1 is. So we have to prove this. So I'm just copying the left side of the equation. And so we know that cotangent theta squared is B squared over A squared from here. So that's B squared over A squared. And instead of 1, we can write A squared over A squared, because it's just 1. And if we add them up, we get, so the denominator is going to be A squared, and the numerator is going to be A squared plus B squared. And Pythagorean theorem tells us that A squared plus B squared equals C squared, where this is A, B, C. And so we said that, so from here we got that cotangent theta squared plus 1 equals a squared plus b squared over a squared. So this equation, the Pythagorean theorem, says that a squared plus b squared is just c squared. And the denominator is a squared. So we get that cotangent theta squared plus 1 equals c squared over a squared. And we know that cosecant theta squared is in fact c squared over a squared. So this whole thing is just going to be cosecant theta squared. And just like that, we proved that cotangent theta squared plus 1 equals cosecant theta squared.